What if the sun, our precious source of light and heat, got swallowed by a black hole? Or even more worrying, what if such a black hole was brewing inside our star right now? Would the sun eventually collapse in on itself, pulling along everything in the solar system? Well, if a medium-sized stellar black hole, formed by the gravitational collapse of a star, swallowed the sun, we would only have around 8 minutes before things went haywire. But if our star swallowed a tiny primordial black hole, we could probably have a chance to survive. The existence of primordial black holes hasn't been confirmed yet. These hypothetical black holes are believed to have formed right after the universe was born. Unlike supermassive or even stellar mass black holes, primordial ones are typically tiny. Their mass is roughly the same as the mass of an asteroid, and their size is no larger than that of a baseball. You can find primordial black holes in a few theoretical models, which have been used in attempts to explain loads of mysterious space stuff, from hypothetical Planet X to dark matter. There's actually a theory that primordial black holes could actually be dark matter. If primordial black holes indeed existed, they could appear because some regions of space were hotter, others were cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though? These holes might be so small exactly because they popped up right after the Big Bang. The thing is, the longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our sun's and that of a pea. There you go. By now, the smallest primordial black holes have most likely evaporated away, but some bigger ones can still be scattered out there in space. Many theoretical models claim that primordial black holes are so common that it's kinda inevitable for a random star to capture one. Such stars with black holes at their centers are known as Hawking stars. So, what might happen after such an accidental acquisition? At first, a captured primordial black hole isn't likely to have any effect on a sun-like star. After all, compared to our massive star, an asteroid's worth of mass might as well be a speck of dust. The black hole simply isn't able to consume much of the sun, but with time, its persistent presence in the heart of the star can start affecting things. The black hole is likely to begin consuming matter in the stellar core, growing over time. If this process is fast enough on a cosmological scale, the black hole can end up swallowing the star completely. If the process is too slow, it might still influence the development and lifespan of the star. Mostly, it depends on the initial size of the primordial black hole. A large one with around 1/1000th of the solar mass can potentially consume a star in less than 500 million years. If something like that has ever happened, there must be solar mass black holes out there, too small to have been created by supernovae like regular stellar black holes. If the primordial black hole is way smaller, 1/1000th of the solar mass, things might get complicated. This tiny hole will keep munching on the star's core, but at a very slow pace. And still, it will stir things up in the core of the star, making it heat up more than usual. Eventually, the host star will swell into something cooler and redder than usual red giant stars. Plus, the turbulence at its core is likely to affect the surface activity of the star. Since we haven't observed anything like this happening to our sun, it's very unlikely that there's a primordial black hole at its center. But we can't say for sure that there aren't other stars hurtling through space, carrying primordial black holes in their hearts. What occurs when a star depletes its energy reserves? Interestingly, it balloons to a magnitude many times its original dimension. This happens because, as the star's core exhausts its hydrogen supply, it begins to shrink due to its gravitational pull. Yet, hydrogen fusion still persists in its outer layers. As the core shrinks and heats up, the external layers also get warmer, leading to their expansion, enlarging the star's radius. As it expands, the star consumes everything in its path, even possibly its own orbiting planets. Although astronomers have observed stars on the brink of, or just after consuming planets, witnessing this event in action remained elusive. However, a groundbreaking discovery by researchers from various institutions revealed a star in the act of devouring a planet. Astonishingly, this cosmic drama unfolded not in a distant galaxy, but within our very own Milky Way, a mere 12,000 light-years away. And the subscribe and like button is only a few centimeters away. Go ahead and click. Thank you. Astronomers observed an intense flare from a star, whose mass ranges between 0.8 and 1.5 times that of our Sun, located near the Aquila constellation, resembling an eagle. Its brightness skyrocketed to over 100 times its usual within just 10 days before diminishing rapidly. Intriguingly, this initial fiery burst was succeeded by a cooler, prolonged signal. This unique sequence hints at one possibility. A nearby planet was devoured by the star. Which planet met this fiery end? Experts suggest it might have been a scorching world, weighing anywhere from 1 to 10 times that of Jupiter. Such celestial bodies are often referred to as hot Jupiters. These massive exoplanets, akin to our solar system's Jupiter, complete their orbit around their host stars in less than 10 days. This particular planet had been inching closer to the star over time until it was irresistibly drawn into the star's atmosphere and eventually into its core. This cosmic dining event took place roughly between 10,000 and 15,000 years ago, when the star had been shining for about 10 billion years. Despite its advanced age, the act of engulfing was shockingly swift, like a quick bite. This is in stark contrast to other hot Jupiters, which saw more of a gradual consumption by their stars. It's uncertain to the astronomers if this star has other planets in its orbit, possibly maintaining a safer radius. But even if such planets exist, it could be millennia before they end up on the star's menu. Regardless, with this newfound knowledge, astronomers are keen to spot more of these celestial feasts. One day, our very own planet and a chunk of our solar system will face a similar destiny. Everything familiar will vanish in the blink of an eye, but no need for immediate panic. This event is slated for about 5 billion years from now. That's the estimated timeline for the Sun to exhaust its fuel and swell immensely, consuming the inner planets, Mercury, Venus, Earth, and Mars. Should humanity have settled on another celestial body by then, they'd have front-row seats to this cosmic upheaval. The Sun's luminosity would spike dramatically, casting off matter into the cosmos, and potentially even consuming Earth in its fiery dance. This phase of the Sun's life will span about 10 million years. Once the core temperature reaches 100 million K, a helium flash will occur, initiating the thermonuclear fusion process that synthesizes carbon and oxygen from helium. With this newfound energy source, the Sun will shrink in size. After around 110 million years, when the helium reserves deplete, the Sun will undergo a tumultuous expansion of its outer layers, transforming into a red giant once again. This Sun phase will be marked by intense flare-ups, with its luminosity at times exceeding its current level by 5,200 times. This will result from previously untouched helium remnants entering the thermonuclear reaction. The Sun will remain in this state for about 20 million years. The Sun's mass is insufficient for it to end its evolution in a supernova explosion. After traversing the red giant phase, thermal pulsations will cause its outer shell to be stripped away, forming a planetary nebula. At the heart of this nebula, a white dwarf will remain, a remnant of the Sun's core. This object, incredibly hot and dense, will be comparable in size to Earth. Over countless millions and billions of years, our once radiant Sun will cool and dim. This life cycle is typical of low to mid-mass stars.
On the 2nd of September 2023, India launched its first space probe to study the Sun. This solar mission is called Aditya L1. It's going to travel almost 1 million miles and join 4 other spacecraft that are currently circling a point in space known as Lagrange Point 1. But this Indian mission is different from the rest. How come? Experts call this mission a unique observatory, all because it combines instruments that can shed light on not one, but on 3 crucial questions. The first one is how stars like our Sun sustain their insanely hot outer layer. The next mystery that confuses scientists is how exactly the Sun's magnetic field produces such severe solar storms. And the last one is how the variations in the magnetic field of our star affect the atmosphere of our planet. Aditya L1 has 7 instruments that can help observe the layers of the Sun. For example, with the help of electromagnetic and particle detectors, the probe will examine the Sun's corona, which is the outer layer of the star. While doing it, the spacecraft will be hovering at a safe distance from the Sun, around 92 million miles. Researchers hope that the mission will be able to gather data on the properties of the corona and figure out what causes coronal mass ejections. Those are enormous bursts of electrons, ions, and magnetic fields. The probe is also expected to examine the Sun's lower atmosphere and the boundary between the atmosphere and the interior of the star. Everyone is waiting for the data from the mission with bated breath, especially from its Solar Ultraviolet Imaging Telescope. No wonder, it can help to study solar winds and the way they accelerate, as well as coronal heating. This telescope can also potentially provide images of the Sun's disk in the near ultraviolet for the first time ever. This disk is the outer visible layer of gas and dust surrounding the Sun. One of the mission's tasks is to help scientists figure out how the dynamics within the corona and the Sun's lower atmosphere drive space weather. You see, our star has a massive and pretty complex magnetic field which wanes and strengthens again, reaching its peak every 11 years or so. When it happens, the north and south poles of the field flip. The current cycle is predicted to reach its maximum in 2024 or 2025. It means that solar activity is going to keep rising in the next few years, making this period perfect for collecting data. There are 5 Lagrange points in space where the gravity between 2 bodies, in our case between the Sun and Earth, cancels out. It means that a spaceship can remain there with minimal use of fuel, and L1, which is the goal of Aditya L1, offers a great view of the Sun as a benefit. The Indian space probe is going to join 4 other craft orbiting L1. The satellite is supposed to reach its orbit in the middle of January, and by the end of February, scientists hope to start getting regular reports. The probe is expected to send around 1,440 images per day to the ground station, where these pictures will be analyzed. Aditya L1 isn't the only spacecraft exploring the Sun. Probably the most famous one is NASA's Parker Solar Probe. Its main goal is to touch the Sun. It's flying closer to the surface of our star than any other spacecraft before. Astronomers hope that this mission will revolutionize our understanding of the Sun. For one thing, the distance between the probe and the surface of our star is more than 7 times smaller than that between the Sun and any other spaceship. Plus, over 7 years of hard work, Parker is supposed to complete 24 orbits around the Sun, and at its closest approach, the spacecraft will hang out around 3.9 million miles away from the Sun, which in this situation is very close, and its speed will be about 430,000 miles per hour. If you moved at this same speed, you'd get from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe has its instruments protected from the Sun by a 4.5-inch thick carbon composite shield. It can withstand temperatures of around 2,500 degrees Fahrenheit. But what exactly does the probe do? It dives into the scorching atmosphere of our star, having to withstand insane heat and radiation just to give us a glimpse of what this atmosphere is like. In 2021, NASA announced that the probe had flown through the corona, the Sun's upper atmosphere. Parker managed to take samples of magnetic fields and particles there. It was the first time ever when a spaceship touched the Sun. The probe was designed to travel within 4 million miles of the surface of our star, tracing the flow of energy, studying the heating of the corona, and exploring the acceleration of the solar wind. Hopefully, we'll get the answers to a few long-standing questions, like why is the sun's corona much hotter than the star's surface? What makes the solar wind accelerate? And what is the source of those high-energy solar particles? It's hard to believe, but we actually live in the sun's atmosphere. At first sight, our star looks like a bright self-contained sphere hanging out somewhere far away in space. But that visible edge is just the beginning. The sun's hot corona reaches way past Earth, all the way to Pluto and even beyond. You can't normally see this corona. It's visible only during a total eclipse, but believe me, it's there. The corona has its own weather. Billion-ton coronal mass ejections occur there. High-energy radiation storms rage from the sun's upper atmosphere. Relentless solar winds can reach a speed of 1,000,000 miles per hour, and every comet, asteroid, and even planet in the solar system is affected by those elements. The sun still has a lot of surprises for us. For example, recently, NASA's Solar Dynamics Observatory has discovered a large coronal hole in the southern part of our star's outer atmosphere. The temperature there can reach millions of degrees Fahrenheit. Such giant coronal holes can have a dramatic impact on our planet. They mean that the sun produces and sends off streams of gas that can easily reach Earth. This can result in geomagnetic storms, triggering disturbances in the atmosphere. At the same time, such solar flares also produce some of the most beautiful phenomena on Earth, the aurora borealis. But since the flares affect our planet's magnetic field, they can have an impact on GPS mapping, satellite television signals, and even cell phone transmission. How bad it gets depends on the intensity of solar flares. Another rather frequent occurrence of this natural phenomenon is power grid outages. Luckily, Earth's magnetic field does a great job protecting us from solar flares. But sometimes, the flares are just too powerful to go unnoticed. Some of them can release 10 million times more energy than the most powerful volcanic eruptions. Within a few minutes, one flare can give out billions of tons of charged particles. Solar flares are also insanely high. Their temperatures can reach several million degrees Fahrenheit. Now, the following news may sound scary, but there are also super flares. In comparison to them, our sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce super flares. But while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth. Or not.
From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled. Sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. but it brought something incredible: two stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus, the strongest ones, X-class flares, have been getting stronger and more common than before, too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all. What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation, Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing: the star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance. But even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system: Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light-years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw 2 of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
Is it possible to put out the sun? For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing: the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam! But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, "Thank you for your help." And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome! Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep-sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
and we'll start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs. Let's face it, as stars go, our sun is actually, well, pretty boring. Come on, there's nothing unusual about it. There are millions of similar yellow dwarfs in the universe. And yet, we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like that. Once upon a time, the sun had a twin, possibly an evil one. What happened to it? Well, let's find out. Now this here is a giant molecular cloud. They're also sometimes called dark nebula. Here, there are many interstellar clumps full of gas, dust, and piles of stars. These clouds have no clear boundaries and often take weird, crazy forms. You can even see some of them with the naked eye. Look at the clear sky at night. They look like dark spots all across the bright Milky Way. And this is exactly where our sun was born about 4.5 billion years ago. The sun originated from one of these molecular clouds. Billions of years ago, waves of energy were passing by here. They collected all this material and compressed these clumps into dense nuclei. That's when a protostar was born. This young protostar was a ball of lukewarm hydrogen and helium. And then, millions of years later, the temperature and pressure inside the balls increased. As a result, a star was born, the sun. But not everything in this molecular cloud has turned into the sun. The remaining materials began to revolve around the new star. And, as you might have guessed, they gradually turned into planets, including our Earth. This is how our solar system was created. But it's quite possible that this is not the whole story, and that at the same time, along with our star, another one was born. The lost twin of the sun, made from the same materials under the same conditions. But why do we think that it exists? Well, recently, scientists have launched some statistical models to find out more about the birth of stars. And these models have shown that many stars appear not individually, but in clusters, or at least with one sibling. After more research, scientists confirmed that, yep, most stars formed inside molecular clouds are born with a companion. Sometimes these companions stay together. For example, a small star will revolve around a large one. They can even form double, triple, and other star systems. And sometimes their paths may diverge forever. This probably happened to our sun as well. It could have had a sibling too. Perhaps not even one, but a whole cluster of little brothers and sisters. And one bigger twin with a similar mass and other characteristics. But if that's the case, then where are you, our lost twin? Well, we have one hypothesis, and according to it, this twin may not be as good as it seems. In the 1980s, scientists began to notice a certain pattern in the Earth's history. Approximately every 27 million years, give or take, large-scale extinctions occurred on our planet. Pretty strange, right? Every 27 million years in the history of Earth, some kind of catastrophe occurred that changed its biosphere forever, as if something, as scheduled, cyclically, caused them. Then an astronomer, Richard Muller, suggested that there may be something that caused the events, a certain celestial body. According to him, it could be a dwarf star that we can't see because of how dim it is. It could be located about 1.5 light-years away from us. This star rotates around the Sun in a huge orbit, and it approximately takes a whopping 27 million years for it to finish its orbit. And when it gets closest to the Sun, it starts to cause complete chaos. While approaching us, this troublemaker changes the trajectories of comets in the Oort cloud or the Kuiper belt. As a result, all these comets start to rush straight toward us. Then they crash into the Earth and cause mass extinctions, just like it was with dinosaurs. This hypothetical star was named Nemesis. It's the name of the ancient Greek deity of retribution. What is it taking revenge on us for? No idea. Perhaps it didn't like the fact that once upon a time, the Sun took away almost all the dust and gas from a molecular cloud. The Sun became a fairly large star, but the twin remained dark and small. Moreover, in the end, it was forced to fly away in the middle of nowhere. Anyone would be annoyed by something like this. Scientists have put forward various hypotheses about what the mysterious Nemesis is. Perhaps it's a brown or red dwarf, the remnants of a star that has completely depleted its fuel. Or maybe it's not a star at all, but a rogue planet more gigantic than Jupiter. Well, whatever it is, its existence isn't particularly pleasant for us. However, all our attempts to find the culprit unfortunately failed. At the moment, we still haven't found any signs of Nemesis. Recent studies have called into question the theory of regular mass extinctions. If you look more into fossil records, you'll notice that these catastrophes occurred rather randomly, rather than on a clear schedule. Now scientists doubt if Nemesis may actually exist. They also say that any star moving in a similar orbit would be very unstable, and it's very unlikely that it could have survived for that long. But despite the lack of clear evidence, Nemesis had become quite famous online. Many articles and news still mention it in different contexts. They like to write off any dramatic events taking place in the world, like asteroid falls, tsunamis, and so on this mysterious star. So now, all this may seem like a typical urban legend, but let's not forget about something important. Even if Nemesis itself doesn't exist, it doesn't mean that the Sun didn't have a twin. First of all, everything we talked about at the beginning is still relevant. Most stars aren't born alone. The probability that our Sun also had a sibling is still very high. Secondly, there may be evidence of the existence of this lost twin, and is probably somewhere in the Oort cloud. This is a huge cloud in the outer limits of our solar system. It consists of a bunch of comets and other cool rocks. Now, scientists believe that this cloud stores various remnants and fragments of everything that remained after the birth of our solar system. It's like a huge museum of our past. So, in this Oort cloud, scientists have noticed something interesting. Basically, this region seems to be too heavy. What the Oort cloud actually looks like doesn't correspond to our current models of the formation of the solar system. It's too heavy because there are some remnants of something in it. So, there used to be something in the solar system that we don't know about yet. But when scientists included a possible second sun in their calculations, it fit just right. Like a missing piece of a puzzle, the lost twin perfectly matches the gap in the weight of the Oort cloud. So yeah, the Sun almost certainly had a twin. But what happened to it? And where is it now? Unfortunately, this star is most likely already very far away. Probably after their birth, the Sun and daughter, Sun 2.0, spent only a couple of million years together, and then they had to separate completely. Now, the second twin may be hundreds of light years away from us, It can be anywhere in the Milky Way. And yeah, theoretically, we could find it, but that would be quite difficult. To do this, we need to find all the stars similar to our Sun, about the same age, all over the Milky Way galaxy. And even if we make a list of these stars, what's next? We have no way of knowing which one was really the twin of the Sun. So, the lost twin will most likely remain lost, and our Sun will remain forever lonely. Ah, what a sad story. But cheer up, for us it's probably the best. If we had two suns, perhaps the solar system would never have become what it is now. Our planet might not exist at all, and that means that there might be no life. So, we probably should be grateful for the sun's sacrifice. On the other hand, our sunsets would look like the ones they have on Tatooine. Cool.